The normal distribution is perhaps the most frequently used distribution when discussing continuous random variables. It has several uses in statistics, some of which include its use in hypothesis testing, creating confidence intervals, and calculating p-values. Some variables that could be described using the normal distribution include the weights of various objects, classroom sizes, total snowfall amounts, and race times. The normal distribution has the following probability density function. F of x equals 1 divided by sigma times the square root of 2 pi times e to the power of negative x minus mu squared divided by 2 sigma squared. In this equation, mu is the mean of the distribution, and sigma is the standard deviation. The terms pi and e are constants. The normal distribution is symmetric about the mean. Here is a typical drawing of the normal curve. We refer to this as the bell curve because the curve has a bell-like shape. The characteristics of the bell curve are defined by two key parameters, the mean, mu, and the standard deviation, sigma. The total area under a normal curve equals 1. Because the mean of the normal distribution is also the median, it divides the area under the curve into two equal areas. 50% of the area is to the left of the mean, and 50% of the area is to the right of the mean. No matter the values of the mean and standard deviation for a normal distribution, the area under portions of the curve are consistent. 68.26% of the area is within one standard deviation of the mean. 95.44% of the area is within two standard deviations of the mean. 99.72% of the area is within three standard deviations of the mean. Different normal distributions can have different means and standard deviations. We can standardize all normal distributions so that they all have a mean of 0 and a standard deviation of 1. This is called the standard normal distribution. The standard normal distribution is a normal distribution of standardized values called z-scores. A z-score is measured in units of the standard deviation. For a normally distributed variable x with mean mu and standard deviation sigma, the z-score for the value x is the number of standard deviations x is above or below the mean. Z equals the difference between x and mu divided by sigma. Note that if x is less than the mean, the z-score is negative. If x is greater than the mean, the z-score is positive. Let's standardize a value. Suppose the grades on an exam are normally distributed with a mean of 77 and a standard deviation of 4. What is the z-score for a grade of 83? In this case, the value for x is x equals 83. The mean is mu equals 77, and the standard deviation is sigma equals 4. Now calculate the z-score. Z equals 83 minus 77 divided by 4. 83 minus 77 equals 6, and 6 divided by 4 is 1.5. The z-score is 1.5, which means that the grade 83 is 1 1/2 standard deviations greater than the mean.